Right, I thought I'd have a go at this meters per second squared thing, which is basically a unit of acceleration, and try and explain where it comes from. So first, we're going to start with change in position. We're moving in one direction, so it's a vector quantity. So we've got this little man down here, this little stick man, is at 0, and it's going to move position and end up 20 meters away. So as change in position is as final minus as initial, so as total change in position is 20 meters. So that's as your units of meters. And now we'll move to velocity, which is the rate of change of position, and that's in meters per second. That's the unit, meters per second. So we've got this little stick man, starts at 0, moves to 20 meters. So velocity is the change in position over the change in time. Position in meters, time in seconds. So we know move 20 meters, just say it took 10 seconds. 20 divided by 2 equals 10. So the velocity is 10 meters per second. If you walk for 2 seconds, obviously you get to 20 meters because you're walking at 10 meters per second. So now we come to acceleration, which is the rate of change of velocity, and it's in the units of meters per second squared, or denoted like this. So acceleration is equal to the change in velocity over the change in time. The unit for velocity is meters per second. The time is in seconds. So acceleration could be written in terms of gravity 9.8 meters per second per second. So for every 1 second, your velocity increases by 9.8. So if this was 1, it'd be 9.8. If this was 2, it'd be 19.6. If this was 3, and so on. So you're not squaring the seconds, you just times it by the amount of seconds. But what it's saying is for every 1 second, your velocity increases by 9.8 meters per second. Right, so we've got as acceleration as change in velocity over change in time. Velocity is in meters per second, and it's times in seconds. So we've got a fraction here. So if we want to tidy it up algebraically, put that over 1, and then we can multiply across by the reciprocal of the bottom half of this fraction. So we can do both sides with that. So that'll be 1 over s, and that'll be 1 over s. So 1s is s, s1 is s, m1 is m, and seconds times seconds is seconds squared. Seconds divided by seconds obviously is 1. So what we're left with here is meters per second squared, or more commonly written as meters per second squared. So it's just denoted that way because it's just cleaner, tidier, but that's exactly what it means. So acceleration is equal, that's your number. That's for gravity. It could be anything. It could be 20 meters per second. It could be 100 meters per second. But that's all it's saying is that's your unit of meters per second, and for every 1 second, your velocity increases by this. So when you're arguing against it, because it's written with a squared term in, because that's just the way it's denoted. Because like I say, if you look at that, you know, if you had to write that in equations all the time, it'd be a bit clunky. Just writing, you know, 9.8 meters per second squared, it's just a lot tidier. But it means exactly the thing that you keep arguing against. You know, it's per every 1 second. Yes, it is. For every 1 second, your velocity increases by that, whatever this number may be. It's just the way it's denoted. You're not squaring any seconds there. So there you go. Hopefully, well, yeah, I say hopefully, that'll make no sense to you, but you know, what you're arguing against is basically what it is. You know, you're saying what it actually is. You just don't understand how it's written and what it means, but it means exactly what you're arguing it means, which is quite funny, to be honest.